So here's another video on interfacing the Pico to the ADS1115. We're only gonna be interfacing it. There's no data being sent wireless, just interfacing the ADS115, which is an ADC chip. It will be connected to I2C port number 1. That means SCL will be connected to GP15 and SDA to GP14. We'll be using a potentiometer to test the voltage output, and the output will be connected to A0 of the ADC. The address pin is connected to ground. That will give us an ID of 72, and that is about it. So here is my setup. It's the same of what you saw in the picture. I have a voltmeter connected to measure the voltage as I rotate or make changes to the potentiometer. So we should be able to see the same output on the Pico, same output we see here. Now, for communications, the datasheet says that if you connect the slave address pin to ground, your address should be 72. And that's what I'm expecting to get. Also, this chip only has 4 registers, which we're only going to use 2. 0 for reading the value being converted, and 1 to trigger the next conversion and set the configuration as well. That one. So first thing we want to do is get the ID of the ADC and then read this configuration and see what we need to do to make changes. So we'll start by importing uTime. Also the I2C and pin, and we'll need to create a device connection on port 1 with a frequency of 400K, and we said SCL was going to be on GP15 and SDA on GP14. So let's see how many devices we have connected. Scan will give you the list of devices, so we can just loop through them. And this will give us the ID. So we have one, which is 72. According to the datasheet, it matches. Now let's go read the configuration, which is register 1. And to read the configuration, you first write the memory address you're going to read, or the register, and then you read it. So we'll write to 72. Actually, let's set a variable here. And it will be register 1, right, or address 1. And then we read it. We're going to read 2 bytes. And we need to get the 2 bytes and put them into a single byte. So first it will be the most significant bits, and that will be byte number 0. We shifted 8 bits, and then we do the second one, 1. And let's print it, see what we get. All right, so here's the configuration. So what do we need to do to read some data? Well, first, since the default mode is set by bit number 8, and the default mode is 1, which means a single shot, so it's not converting anything until you tell it to convert. And the way you do that is just set bit 15 to 1. and then that will trigger the conversion. And this same bit will give you the status. If it's 0, it's performing a conversion, and if it's 1, it's not doing anything. So you're safe to read the value in register 0. We're also going to be reading A0, which is this one here, right? So it will be bit 14 set to 1 and 12 and 13 to 0. And then because the Pico is running off of 3.3 volts, we want to get the maximum resolution. So we're going to use this one, which the maximum resolution on this one is plus or minus 4.96 volts. We don't want to go higher because the resolution goes lower, and we don't want to go lower because then we won't be able to read the higher voltages and lower voltages. So it will cap out at 2.048 volts. And this one, it goes over 3.3, but it will give us the maximum resolution. So we'll set bit number 9 to 1 and 10 and 11 to 0. So let's start by reading the configuration. Oh, we already read the configuration, so let's put this in a function. And we'll just return this value, which means that we can read config here. It should give us the same result. So let's create a second function, and this one will be read value, and this one will be using the same lines, except this one is for register 0. And every time we read the value, before we return the value, we're going to set the configuration for the next read or for the next conversion. So we do that by first reading the configuration, and this is the same function we create here. So we're just going to call it to get the configuration. We'll clear bits 12 to 14 and 9 through 11, and then we'll set them every time we read. So we'll say config, and let's clear those bits. So it will be 12 and 9. Okay, so that will clear 9 through 11 and 12 through 14. And if you're curious why it's a 7 on 12, is because the 3 bits, this is value 7. So number 1, the first bit represents a 1, the second one a 2, and the third one a 4. So 4 plus 2 plus 1 equals 7. And you start at the beginning on 12, and it'll clear the next 2 as well. So 3 bits are clear. Then we set the configuration we want on those. And we're going to set this one here. That's a 4. That's the third bit. And on this one, we're going to set the 9 to 1, which will give us the maximum resolution. This one here, because we're running at 3.3 volts. If we were running at 5, then we would use this one here. And the last one, we need 15, this right here, to trigger the conversion. Then we write it. Configuration plus config. But before we do that, we need to change this, convert it from a single value to an array of 2 bytes. So we can do that here. Config so that will give us what we want, and I believe that is it. So we're reading the value, well, we're writing the address of what we're going to be reading, and then we're reading that value from that address, storing it in result. Then we read the configuration, clear a few bits, then set the bits for what we want to do, which is A0, that's port A0, and then the resolution we want, and then trigger the conversion, or the next conversion, if you will. We change the config to a 2-byte array. We write it back to the configuration. This is register 1, right? Plus the configuration, and then we return the value we got on line 22. So that means that I can set in a loop here and get the value, read value, and print value. Actually, we'll just do equals and value, or value, like that. And if I did it correctly, we shouldn't get errors, but we got some errors. Line 28. Let's see. Syntax error. So config and config shifted to the right for in. Okay, I was missing this. So there's the data, right? That's let me stop it. We want to put a delay here, and let's set it to 1/10 of a second. Run it again. Here's the value. So if I move the potentiometer, you can see the voltage changing, but also the value is changing. So let's get the max for 3.28 volts, and we get the max is 2250, 26250, I'm gonna say. So having that value, we can convert it to an actual voltage, and we'll say volts equals, and this will be the 3.3 volts divided into the 26250 multiplied by the value, and that should give us the voltage. Alright, so there is the voltage. So here's the voltage, very close to this value. So if I move this, so there you have it. Pretty simple. Enjoy.